In this last problem, it says a sample of gas has a volume of 43.1 liters at a pressure of 1.1 atmospheres and 80 degrees Celsius. What is the new volume at STP? So the reason why I wanted to do this problem was because it incorporates this idea of STP. STP is not just letters that stand for standard temperature and pressure, but it also gives us a set of conditions. And so it's important that you recognize that right away. So we see here that we have got a volume of 43.1 liters, and we've got a pressure one of 1.1 atmospheres, and we've got a temperature one of 80 degrees Celsius, but we obviously cannot keep that. We've got to add 273 Kelvin to get 353 Kelvin. So now we've got our first set of conditions, but it appears from the problem that we don't have a second set of conditions. That's where STP comes in. So volume 2 is what we're looking for, and we know it's going to be in liters. Pressure 2 is STP. The pressure at STP is 1 atmosphere. And the temperature at STP is 273 Kelvin. So don't forget that STP, this is STP, standard temperature and pressure, 1 atmosphere, 273 Kelvin. And now we're just going to solve this exactly like we did before. P1, V1 over T1 equals P2, V2 over T2. Cross multiplying, we get P1, V1, T2 equals P2, V2, T1. And again, we're going to solve for V2. So V2 is equal to P1, V1, T2 all over P2, T1. So given that, now we can solve for our second volume. So pressure 1 is 1.1. We're going to multiply that by volume 1, which is 43.1. We're going to multiply that by temperature 2, which is 273. And we're going to divide all of that by pressure 2, which is 1 atmosphere, and multiply that by temperature 1, which is 353 Kelvin. All right, so now we can in fact put that into our calculator, and we will get 1.1 times 43.1 times 273 equals, divided by, and then in parentheses, 1 times 353, and parentheses, equals, and we get 36.7. Volume 2 is 36.7 liters. So the important part of this problem is understanding this right here, that STP is its own set of conditions.